All right, class, today we are studying special factoring patterns and tricks to factoring. We are going to be able to factor trinomials and factor by grouping. A polynomial is considered to be factored when all factors are prime, meaning that each factor cannot be factored any further. So let's take this first one for example. I notice that I have a greatest common factor between these two terms of 2x. So I'm going to take that 2x and factor it out. Inside of the parentheses, I divide each term by 2x and write the remainder. So I have 3x squared, and 4x divided by 2 would be 2x. I cannot factor this portion on the inside any further, so this would be the prime factorization. Let's look at the next one. Again, I look at every term, and I think to myself, what does each term have in common? I notice each coefficient is divisible by 3, and every term has 2 x's in it. So I'm going to factor those x's out. So the greatest common factor is 3x squared, which means that I am left with x squared plus 3x plus 2. And looking on the inside here, if I can factor this any further, I should. So follow your AC method pattern. We have factors of 2 that add up to give you 3, so that would be 2 and 1. Since the leading coefficient is 1, I can go ahead and break this trinomial down further to say x plus 1 times x plus 2. And so this would be the prime factorization. Again, each factor cannot be reduced any further. The difference of squares is a very special factoring pattern. The key thing to notice with the difference of squares is that you have a perfect square subtracted from another perfect square. When you have a perfect square subtracted from a perfect square, the factorization is simply x is simply the square root of the first term and the square root of the second term with a plus and a minus between the two. You could also think of this as factoring a trinomial with the b term or the middle term being 0. Either way should get you to the same answer. So let's look here. The first thing I always ask myself is if I had a greatest common factor, and I do. The greatest common factor between these two terms would be 4. So if I factor a 4 out, I have 4x squared minus 1. Now, since I have two terms and they're subtracted, I wonder if I have the difference of squares. 4x squared is a perfect square, and so is 1. The 1 times 1 is 1. So I can automatically break this down. I know I'll have two sets of parentheses. One of them will have subtraction, one will have addition. So the square root of 4x squared would have to be 2x and 2x, so those two numbers have to be the same. And then the square root of 1 is just 1. Here we go, the prime factorization. The sum and difference of cubes is a very important rule for you to remember that you might not have necessarily done that much. We can have addition of perfect cubes or subtraction of perfect cubes. In the previous example, it's only the difference of squares. We can only have subtraction. The pattern follows the same. It uses the cubed root of the two numbers. If you have the sum of cubes, then you add the two terms that are cube rooted, and then you follow this pattern. Square the first term, multiply the two terms, and then square the second term. This sign here and this sign here will always be the opposite. The pattern follows the same with the difference of cubes. Notice the subtraction here and the subtraction here are the same. We subtract the terms, We square the first term, multiply the two terms, and square the last term. And those two numbers are opposite. So let's do an example with this. A very simple one would be x cubed plus 27. Now I know this will follow the factoring pattern of the difference, or the sum of cubes, because I have a perfect cube and a perfect cube. So it might help to write out your terms. My u term would be x, or the cube root of x to the third. And my v term would be the cubed root of 27, which is just 3. So then I can follow the pattern. My first set of parentheses is going to be adding. And then my next set is square the first term, multiply the two terms together, and then square the last term, or square the v term. This term is always going to be a plus. These two are always opposite, so if that's adding, that's subtracting. And this would be the prime factorization. The final factoring pattern to consider is factoring by grouping. When you factor by grouping, typically you have 4 terms. Factoring by grouping will not always work, but in this case it will. When you factor by grouping, you do exactly what it says. You're going to group the terms together. So I'm going to group the first two terms together and pull out the greatest common factor. Between x cubed and x squared, the greatest common factor is x squared. Every term gets divided by x squared. And so I'm left with x minus 2. I do the same thing here in my second group. Remember, I never want my x terms to be negative if I can avoid it. So I'm going to factor out a negative 3 from both terms here. If I factor out a negative 3, the x becomes positive. And I divide 6 by negative 3, so I end up with negative 2. If you factor by grouping correctly, then these two sets of parentheses should be the same. Their other factor is just the portions that you pulled out. So x squared minus 3. Sometimes you might be able to factor this part further. In this case, you cannot. So this is our prime factorization. If you have any questions, please write them down, and we will discuss this more in class. Have a good day.